In this video, we are going to implement two API endpoints in the order service. One is to fetch all the orders created by a user, and another one is to return one particular order details for the given order number. And we are going to write integration tests for it. And also we are going to Dockerize this order service by writing necessary Docker Compose configuration files. So let's get started. Let us start with our first requirement, implement getOrders API. Here we can see the expected response is a list of orders, and each order contains only the information about order number and status only. We are not including all other details about the order. So if you think of from the user experience point of view, usually in a list page we only see very few details about the entity, and then when a user selects a particular order, we will show more details about that particular order, right? So this is the list API endpoint, which only contains fewer fields. We don't need to include all the information about the order. So now we are going to implement that in our order service. So currently we have order controller, which has one API handler to create the order, and we are going to implement the new API endpoint like this. So we have get orders with a get mapping. So at the class level we have request mapping /API/order. So we don't need to specify anything at this annotation level. So now coming to the implementation, we are returning list of order summary. Here, if you take a look at the order summary, I have created a new model under domain models package, which contains only order number and status only. So now with this, let us see how we are implementing this. So first, we need to return only the orders of the current logged in user only. So here, if I go to this method, currently we are hard coding this. Even while creating the order also, we are using the same method. So currently, whenever a new order is created, it is going to create with the same username. So while fetching also, we are getting the same username. Once we have implemented OAuth based security, we will actually implement to figure out who is the actual logged in user, and then we are going to fetch orders for that particular user only. So now let us go and check how the implementation for order service.find orders is. So here we have created a new method in order repository called find by username. So this is called spring-data-jpa derived query method name. So what it does, spring-data-jpa will remove this find by prefix and then construct the where class based on the remaining method name. So here we have only one field. So it is going to be like select star from orders where username equals to whatever the value we are passing here. And it is returning the list of order entities. And in our service, we are looping through all the orders, and then we are constructing order summary by taking order number and status from the order and returning the list. So now this is going to work, but it is a very bad implementation. Why? We are fetching the entire order information from the database, from the repository, and then dropping all the information except order number and status. So unnecessarily we are loading all the order information only to use order number and status only. So we should not do this. So instead, what we can do, from the find by username itself, instead of using the derived query, we will provide our own query implementation using the JPQL. Okay, so here it is giving some auto completion. So let me see, from order entity giving the alias O, where username equals to whatever the value we are passing. So this is fine. But instead of returning the order entity O itself, we are using this constructor expression, new, and giving the complete fully qualified name for order summary, and then passing the O dot order number, O dot status. So we are constructing a new order summary instance for every record that is matched with the username. So here, instead of returning order entity, we can return order summary itself. So it is not going to load all the information about the order. It is going to only read order number and status only, and then return list of orders summary directly. So from here, we can straight away return from this method itself. We don't need all this. So this way you are reading only the data that is required for your API endpoint. You are not loading the unnecessary data only to discard all that information. Okay, so this is how we can implement this get orders API endpoint. Okay. Now let us look at the second API endpoint. Here we want to get one single order information for given order number. So we are going to include most of the information about the order as part of the response. So now let us take a look at how we are going to implement this API endpoint. So in the order controller, I have added the next API handler method here using get mapping, and we are going to add this /API/orders/order number, and we are binding that value to this path variable order number here. So now again we are getting the username, and in order to fetch the order number, we should not be exposing this API endpoint so that anybody can simply pass the order number and get the order information. It should be the order number should be owned by the current logged in user. So we are fetching the username and then taking the order number and then trying to find the order based on these two factors. So here we are calling order service dot find user order. So if somebody, if they want to exploit this API and they are logged in as a different user but trying to give the other user's order number, still it is not going to get the specific order information. So here we are trying to find the order for this order number, and it should be created by the current logged in user. So what we are doing in the find user order, so here we have created a method in the order repository which is going to return order entity. So here if you go to this find by username and order number, and we are passing this username and order number. So with this we are returning this order entity optional, because with these two combinations there may or may not be the order. So we are returning optional of order entity. But here, as we have already discussed, how spring-data-jpa is going to execute this, it is going to remove this find by prefix and then trying to construct the where class where username is one column, order number is another column, and is going to be used in the where class. So it is going to be like select star from orders where username equals to this value and order number equals to this value. So it is going to do like this. And once we got the order entity, we are mapping it to using a order mapping. So we are taking the order entity and then mapping the order items and then mapping it to DTO. So we have created a new order DTO. The reason being, earlier also we might have discussed, we should not be directly exposing our entities as a response to the API endpoints, because if we want to change any logic, it is going to affect both the places. So instead we are returning a DTO with only the necessary information. Here we are not including the order ID, which is the primary key in the table, which is not required for the response. We are not including that. And then also we are not including updated it, which is not required. So here we are including only the fields that is required for this. And then we are also including a derived property to return the total amount. So it is going to loop through all the items and then multiply quantity and then returning it. So we are returning order DTO instead of directly exposing the entity itself. So that's what we are converting here, and then we are returning this optional of order DTO. And at the controller level, we are taking that, and then if there is no order found with this combination, we are throwing this order not found exception. Okay, but here there is a catch and we will talk about it. But first I have started both the databases and then rabbitmq, and then I am going to start both catalog service and order service and then demonstrate what we can do better in this process. So here let us go to order service and then restart. Also I am going to enable showing the SQL that is generated. so that we'll see what kind of a sequence it is getting generated. So I'm restarting the order service again. Okay, so now let me go to Postman, and here first let us try to fetch API orders. And here, so these are some of the orders that earlier we have placed, and now if we check the console, it is going to run this query. So all the other queries are from batch jobs. So this query, it is selecting only order number and status. It is not selecting all other details. So that is what we have done in our repository by returning this order summary itself using this constructor expression. So it is not selecting any unnecessary data. It is only selecting order number and status only. Okay, that is fine. But now let us take a look at another one. So here I am taking this order number and then going to fetch that particular one. So API/order/order number, and if I'm fetching it, yes, I am getting the data. But now let us take a look at here. First, it issued a first query to fetch from the orders, and then it issued a second query. Where is this? Let me clear the logs and then try it once. So here we can see there is a second query fired to fetch its associated ordered items. So it is firing two separate queries because we are not specifying. If you take a look at order items, here it is going to by default load lazily. So it is triggering another query to fetch the associated order items. So that is not a optimized way. So instead what we can do, we can write a custom query again. Okay, so here now we are returning O itself. So here with the custom query, select order entity O, left join fetch order items. So it could be items itself. So here what we are doing with the custom query, we are selecting order entity O and left join fetch order items. So with this, it is going to join order items table and then fetch all the data in a single query. So here we can say distinct O and put in the where class username and order number. Okay, so now let us see how many queries it is going to generate. Let me restart this. Okay, so now if I go to this and then run this, now you can see it is triggering only one select, and here we can see it is left join fetch order items. So both order details and its associated order items are fetched directly in a single query. So that way, so it is very important when using spring-data-jpa. It is very convenient. You simply write one query using the method name and then it is magically going to fetch the data. But it is always important to check the logs and see what kind of a queries it is being generated. And then you need to tune it so that it is not going to run multiple queries, or there is a common problem known as n+1 select. So you need to be careful and always check the SQL queries that are being generated and then try to fine tune it. Okay, so now we have seen both the API implementations here, and we have manually tested using Postman also. Okay, so now let us write integration test for it and then see how we can test this. Earlier we have created order controller tests for writing integration tests, and then we have created a nested class to put all the create order related tests inside this class. So though we have currently couple of tests in this nested class, so similarly you can group all the API endpoint tests for a specific API endpoint and you can test various scenarios. So similarly we are going to create another class for get orders tests, and also get order by order number test. So though we have currently only one test is there, but you can add more scenarios and follow the similar pattern here. So what we are doing, we have created under src test resources, I have created a SQL script called test orders.sql file. So in this, what I'm doing, I'm truncating orders and putting cascade, which means it is also going to delete the entries from order items table. And then I am altering the sequence with 100 to start with 100, so that I can set up some sample data. And when there is any other API that is trying to insert a new entry into orders, it is not going to clash with this IDs. It is going to start with 101 or something like that. Okay. So here I am trying to insert a couple of rows into orders table, and then inserted a couple of records into order items, associated order items. So here we have two orders, and then for order 1 there are two order items, and for order 2 there is one item here. So I have created some sample data so that we can run our tests against this data here. So once I created that script, I am using @SQL and specify the path of the file, the SQL file. So by default, if you don't specify anything, it checks for class path also. So it is there in our class path, src test resources. Okay. So now for every test method, it is going to run this SQL script, so that even if you make any changes like placing order or updating anything, it is going to remove all that orders and then reinsert this sample data, so that every test runs in a known database state. So here under get orders test, I have only one test, and then I am issuing this /API orders endpoint, and then I am asserting it should be status OK 200, and I am extracting that response into list of order summaries, and then I am asserting it should contain two orders. Okay, so basically here I am inserting two orders, so I should get two orders only. This is the /API/orders, the first API endpoint that returns all the orders information. And second, here I am taking one order number from the sample data here. So order -123, and I am trying to get the details here. So I am trying to pass that order number here, and then trying to fetch that particular order details, and I'm expecting the status code to be 200 and order number is this. And here, because I know for the order number 1 there are two entries, I am just asserting items size is to be 2. So if you want to add more assertions to compare other fields of the information, you can write those asserts as well. So now we have two other tests added. So now let us run and then see. So the important thing is we should some way make sure that all the tests are running in a known state. That means here we are making sure that we are removing all the existing data and then inserting some sample data, and we are running that script for every test method, so that we always know what is the data that is already there in the database. That's why we are able to specify that it should contain two orders, and we are also saying for this particular order there are two items. So this is based on the sample data that we have. Okay, so now here you can see all the tests are passed. Okay, so we have already seen how to write unit tests using @webmvc test and all. So I am not going to repeat the same thing again. You need to simply mock the response from order service, and then you can write other tests as well. So I'll leave it up to the viewers to try it out, and you can let me know if there is any challenges. Finally, let us complete the Dockerization of order service. So first, let us take a look at our task file. Earlier, we had under build commands, we had only building the Docker image for catalog service. I have added this second command to build the Docker image for order service as well. So the rest of the commands are everything is fine. There is nothing to be changed. And if you go to order service, let us check the properties. So here there are few things that we need to change when you are running inside Docker. Okay, so first of all, orders catalog service URL, when you are running both the services locally, we are pointing it to localhost 8081. But when we are running both the services inside Docker, this host name should be whatever the host name container name that we are giving to catalog service. So this should be catalog-service.:8081. But we can override this property through environment variables in the Docker Compose file. So apart from it, we also need to configure DB URL and everything, and then rabbitmq configuration we can override through these environment variables. So that is all we need. So if I open up this infra.yaml file, we have already seen we have catalog DB, orders DB, and bookstore rabbitmq that we have already configured, and we have been using this for some time. And the new thing is in apps.yaml file, earlier we had only configured catalog service. Now I have added this order service as well, and I have defined this image name and gave the container name as order-service, and then under environment I have configured profile to activate Docker. Right now it doesn't have any impact, but just to know we are running inside Docker, I just enabled this profile. And how do we override this catalog service URL? So basically you can take this property and capitalize all the letters and replace dots or hyphens with underscores and provide it as an environment variable. So this is how we can simply override that. And similarly, we have configured database URL, password, username and all. For rabbitmq also we have configured. So this is the host name, which is nothing but our infra container name here. Okay, so that is how we have configured, and also specified it depends on both orders DB and bookstore rabbitmq, and they should be healthy. Okay, so this is all we need for Docker Compose configuration for order service. So now let us verify whether everything is fine or not. So now I'm going to run the command task restart, which is going to stop if there are any containers running, and then start all the containers: catalog DB, orders DB, rabbitmq, catalog service and order service. All of them should be running in Docker only. So right now nothing is running, only container is running. So let us wait for this. So here it is going to use cloud native build packs and then build the Docker images and then run all of the services in Docker. So all the services are successfully started. Now let us go and check. As you can see, we have bind this port 8082 to host 8082. Similarly, 8081 on host 8081. So we can use these ports and then interact with the catalog service and order service. So now what I'm going to do, I go to Postman and try to place an order. So here now I try to place an order with all the valid information, and it is able to successfully create an order, which means it is also be able to talk to catalog service. Otherwise the validation will be failed, and then I get to see some error here. So now both the services are up and running. Okay, so we have successfully configured everything, and already we have created order service pipeline here for GitHub Actions. And it is also very similar to catalog service. We are building this by running the tests and then logging into Docker Hub and then building the image and pushing it to Docker Hub. So Dockerizing order service is all set. So this is all for order service for now, and in the next video we are going to start building our notification service. Thanks for watching. Bye bye.